Hi YouTube. In this video I will be explaining a parallel circuit. I will be explaining the rules which apply to a parallel circuit. I will be discussing the formulas which are associated with a parallel circuit. And I will be explaining what happens to current, voltage, resistance, and wattage in a parallel circuit. So this is an example or an illustration of a parallel circuit. Now, there's two distinctive things about a parallel circuit that I would like to point out. Number one, there are more than one path for current to flow through a parallel circuit. Example, this is one path, this is another path, this is another path, and this is another path. So there's at least four paths in this particular parallel circuit for current to flow. Number two, the voltage is the same throughout the circuit. So the voltage is the same throughout a parallel circuit. So if we have 24 volts traveling through this path, this resistor 1, you will also have 24 volts passing through resistor 2, 24 volts passing through resistor 3, 24 volts passing through resistor 4, and 24 volts at the power source. So the voltage is the same throughout a parallel circuit. So the two distinctive things are there's more than one path for current to flow, and the voltage is the same throughout the circuit. Now, I would like to show you the difference between what a series circuit look like and what a parallel circuit look like. This is a series circuit which only has one path for current to flow. This, again, is a parallel circuit which have more than one path for current to flow. So there you have. Also, this big huge circuit is called a combination circuit or a series parallel circuit. Some of the resistors are in series and some of the resistors are in parallel. However, in this particular video, we will specifically be dealing with a parallel circuit. So, okay, I'll need to talk to you about the letters that you may see in the formulas associated with a parallel circuit. So you will see these particular letters. You will see an E. The E scientifically stands for electromotive force. But in the electrical field, most electricians know it and call it voltage or volts. You'll see an I. The scientific term for I is intensity. Most electricians know it as current or amperage is measured in amps. The R stands for resistance, is measured in ohms, and the P stands for power. Scientific name is power, also known as true power, but to electricians in the electrical field is known as wattage and is measured in watts. So you will see these letters throughout this illustration in this video. Okay, the rules which apply to a series circuit. Okay, these are the rules. Right quick, I'll run through them. You see E. The rule for voltage, which is represented by E, is the voltage is the same throughout the circuit. So E total is equals to E1, equals to E2, equals to E3, equals to E4. Then you have the current, which is represented by I. The sum of all the individual current passing through each individual resistor equals the total current. And then you can't hardly see that P, but that's a P total behind the screw there. P is equal, the total power is equals to the sum of the power consumed by each resistor. So the power consumed by 1, 2, 3, and 4 equals the total power. Now, the resistance is pretty tricky. The root for the resistance is the total resistance is smaller than any other resistance, is smaller than the smallest resistance. There's three formulas used to find the resistance, and we'll go through those later in the video. So one more time, let's go through the current. The sum of the current passing through each resistor equals the total current. So the current going through 1, 2, 3, and 4 equals the total current. The total current of all the current passing through each pass is 3.44 amps. Okay, now let's look at the voltage. Okay, the voltage is, as I said in the beginning of the video, the voltage is the same throughout the circuit. So if you had the total voltage, which is 24 volts, you know what the voltage that's passing through resistor 1 is also 24 volts. So the voltage is the same throughout a parallel circuit. Okay, now the power, or what we call the wattage in the electrical construction field, it is the total power consumed through each resistor. The total power consumed through each resistor equals the total power. So all the power consumed through 1, 2, 3, 4 equals the total power, or the total wattage. Okay, this is where it gets tricky. It gets tricky here. There's 3 different ways to find the resistance in a parallel circuit. One is called the equal value method. It looks like this. R total is equals to the resistance over the number of resistors, if you can see that. Okay, the reciprocal and also the product sum. This right here does not apply to a parallel circuit. R total plus R1 plus R2 plus R3. That does not apply to a parallel circuit. That applies to a series circuit. So disregard this. Okay, now let's talk about the equal value method. Okay, the way you find the total resistance in an equal value method, the only way you can do it is if each resistor have the same value. And in this illustration, each resistor equals 60 ohms. So the way you find it is the total resistance is equals to the resistance, the value of the resistor, over the number of resistors. So we have 4 resistors, 1, 2, 3, 4, and the value is 60 ohms. So you would say R total is equals to 60 ohms over 4. So the total resistance of this particular parallel circuit is 15. And again, you can only use the equal value method only if the resistors have the same value. Okay, the next method is called the reciprocal formula method. Okay, now what you do with this, if you wanted to find the total resistance, you will plug in the amount of ohms at each one point. You can barely see it. Okay, let me pick it up so you can see it. So here, for this R sub 1, you would take that 30 ohms and you would place it at that R sub 1. You would do the same for R sub 2. You would place 50 ohms where the R sub 2 is. For the R sub 3, you would place 25 ohms. And for the R sub 1, for the R sub 4, you would place 20 ohms. Let's take a look at it. All right, there again. So all I did was where it said R sub 1, 2, 3, and 4, I just placed those values. So I divided 30 ohms into 1 and I got 0.03. I divided 50 ohms into 1 and I got 0.02. I divided 24 ohms into 1 and got 0.04. Divided 20 ohms into 1 and got 0.05. Okay, then I added it all up and I got 0.14 ohms. So I take that 0.14 ohms and divide it into 1 and it gives me my total. It gives me my total resistance, which would be 7.1. Notice the total resistance is smaller than the smallest resistor, which would be 20 ohms. Okay. Now, the last method, which I feel is the easiest to understand, between the reciprocal formula and the product sum formula, I think the product sum formula or the product sum method is probably the easiest formula to learn. Okay, and it states that the total resistance is equal to R sub 1 times R sub 2, R sub 1 plus R sub 2. And you just simply plug in the numbers. So for R sub 1, I plugged in 30 ohms. For R sub 2, I plugged in 50 ohms. So it'd be 30 times 50, and then it'd be 30 plus 50. Then you would then do the division, 80 into 1500. So R sub 1 and 2 combined is 18.75 ohms. Now you gotta go through and do the same with R sub 3 and R sub 4. Let's take a look. All right, so we've combined it, R sub 1 and 2, and it's 18.75. So now we say R sub 1, 2 times R sub 3. And you say R sub 1, 2 plus R sub 3. You do the math, and you come up with R sub 1, 2, 3. So you've combined it 3 resistors, and you've come up with 10.714 ohms. Then you got to now use the product sum method to combine the last resistor in it, which is R sub 4. There again, so the total resistance is equals resistor R sub 1, 2, 3, 4, which we combined it, times R sub 4 and R sub 1, 2, 3, 4 plus R sub 4. When you do the math, you come up with you come up with the total, which would be 7 ohms. And that's how you would actually use the 3 formulas to get the total resistance. So you got the product sum method, which we just did. You got the reciprocal method, which I find the most difficult. And you got the equal value method, which only works if all the resistors have the same value. Now, point out this to you. If you have 2 knowns in one path, you could actually use Ohm's law to find a third unknown. For example, let's just take a look at resistor 2, R sub 2. You have 50 ohms. Now, and you have 24 volts. Now you have a known value of resistance. You have a known value of voltage. And so you can use Ohm's law to find the current passing through resistor 2. Okay? I sub 2 is equal to E sub 2 over R sub 2, which would be 24 volts over 50 ohms equals to R sub 2. And what we have is I sub 2 is equals to 0.48 amps. You see that? Now, you can also use Ohm's law there again if you have 2 knowns to find a third known. Check this out. Okay, we see what the total amperage is. Now, we don't know anything else, but we really do know the total voltage because the voltage is the same. So the total voltage is 24 volts because we know that R sub 2 is 24 volts and the voltage is the same in a parallel circuit. So we do know that the total voltage is 24. Now I can use that to find my total power. I can use this formula right here. P total is equals to E total times I total. So I'll just plug in. So P total is equals to 24 volts times 3.44 amps. And then I can find my total voltage. I can find my total power now. Give me a minute. Got to do the math here. I can now find my total power, which would be 82.56 watts. So if you have 2 knowns in a parallel circuit at any given point, you can then use those 2 to find an unknown, especially if you know what the voltage is, because the voltage is the same throughout the circuit. So what is the voltage passing through R sub 4? 24 volts. Okay, and that explains a parallel circuit. I hope that you could benefit from it. Thanks for watching.